Hello, welcome back. As I promised, another question on related rates of change, which again I've written very recently, but I don't think I've actually put it yet into a paper. I think it will appear possibly if I'm still around on the synoptic. The last three synoptic papers, which is going to be X, Y, or Z, which they'll be coming at some point in the future, I hope. There's a story behind this particular question, a slightly easier version, slightly easier, and I stress that. In 2018 or 2019, possibly, one of my students, he couldn't do this question. It was actually in his school mock. I'll mention the school. It was Enfield Grammar in Enfield, North London. And I just took it and I've just modified it ever so slightly. So I just changed the numbers and it has been modified by making it a little bit harder than what he had. So this is now a 4.5-star question, quite a challenging question. And what it's actually saying, is liquid, you can call it water, is pouring into a container at the constant rate of 2 pi centimeters cubed per second. So I'm going to start recording stuff down because I cannot really leave that piece of paper there while I'm doing the video. So what I have is a constant rate. The units are telling me what it is units of volume per second. So I'm being given dV by dt constant at 2 pi. The container initially contains some liquids. A little bit bizarre. Container initially has some water inside. And when the height of the liquid in the container is 8 centimeters, so we have a container. Let's just draw it here. What shape it has, it hardly matters. So this is now V, and this is the height. And the height of the volume, H is greater or equal to 6. So the container has some water, and when the height of the liquid in the container is 8 meters, where H is greater or equal to 6. Why is it 6? It's probably up to 6 is what the water was to start with. So this 6 here is the initial amount of water that was in there. Okay. And what are we being asked? This is given, this is information. Volume is pi. Actually, let's write this bit here. Volume is pi. And from this formula, we can find how much water in volume was in there. We can just need to plug in H is equal to 6 into all of this. And we need to determine the rate at which the height of the liquid, and what we're trying to find is the rate, something dt. dt of what? The height of the liquid, H. The H by dt is rising 30 seconds after the liquid started pouring in. We need to do a little recap just to make sure, 30 seconds. We have, I'll redraw this picture there. It's a little bit of a mess to actually follow what's going on. I drew it a little bit too small. The shape of the container is irrelevant really. I'm just going to draw a cylinder. Okay. And this is 6. This was the amount of water they contained. So we put it under a tap. And water is going in now constantly at this rate, 2 pi. The pi is there purely to make things cancel. So of course, at all times, the water will be rising. We started with some amount. Okay, where do we go? And what are we trying to find? After 30 seconds have elapsed, let's say the water wasn't quite as high as that. It was up to here. So after 30 seconds, we want to know what is the rate of change of the height. Okay, where do we start with something like this? Okay, the first and obvious things. Let's start collecting some information from all of this. When h is equal to 6, because of course this formula does say h has to be bigger than 6, it's the amount of water that we got in there. So V is pi. I'm just plugging it in there just to see how much water was there to start with. 30 plus 36 minus 16, 30, 66, 50 pi. I like the number because of course it's a nice number. That is already in. So that's the first consideration. The next thing is this 30. This 30 has some significance, this 30 seconds. Water is going in at the constant rate in one, let me just write first of all 2 pi centimeters cubed per second. That's how it was given. It's a units of volume divided by units of time. What does that actually mean? It means in 1 second we have 2 pi centimeters cubed. In 2 seconds, because it's constant, the tap is not being turned on and off faster or slower, it's going to be 4 pi. In 3 seconds, 6 pi. In the desired time, which of course for us is 30 seconds, is 60 pi. So that means for us, in 30 seconds, we have 60 pi extra in. Which means in total, after 30 seconds, the amount of water in the container will be 110 pi centimeters cubed. Where can we go from there? Let's have a little think. The time it takes me to rub off these little workings here. I'm doing some kind of bullet point form. This is a volume. Well, I can definitely find the height of this. The height of this, if I plug it now, let's write it back in black. 110 pi, that's the V, is equal to pi h squared plus 5h minus 16. I'll be able to find the height of this quantity. The pi's cancel. 110 is equal to h squared plus 5h minus 16. H squared plus 5h minus 126 is equal to 0. 126 is a 14 something. I think it is. You can use your calculator for this. You are allowed a calculator. Of course, it's a pure paper. I think it's calculated for most of the papers now, aren't they? 14 times 9, is it? Yeah. Let's see. Yeah, it's 14 times 9. 1 plus and 1 minus. We have more plus. And therefore, I found either h must be 9 or h must be minus 14. The height, of course, it cannot be negative in the physical sense, and therefore h must be 9. I haven't done any related change or what you call it, any differentiation if you want so far. All I have found out so far, which is crucial to this particular question, is 30 seconds is equivalent to the height being 9. And now I can start thinking about what they were asking me. They were asking me to find dh by dt at a specific moment. Let's not worry about the specific moment, and let's think about how we're going to split that. dh top left, dt bottom right. We're going to bridge it in the middle with the only thing that we really like to use is 2 pi. That's the dv by dt. So we can bridge it with a dv. And of course, we have some additional thing to do. If we look now what's going to happen here, we have dh by dt. This is a blank. We'll come back to that. dv by dt is 2 pi. What is dh by dv? In order to find dh by dv, we need to have a formula that connects v and h in some form. We have it, it's here. We just need to differentiate it and come up with something sensible to put in our expression. So v is equal to pi h squared plus 5h minus 16. dv by dh is pi, I'm going to leave it on the other side, 2h plus 5. Do we want it like that, or is it upside down? It's upside down, so dh by dv will be 1 over, and conveniently, again, the pi's will cancel. So that's going to be 1 over pi 2h plus 5. And the game is up now. The pi's cancel, and therefore I found what I needed to find. dh by dt evaluated when t is equal to 30, in other words, after 30 seconds, is equivalent to finding dh by dt when the height is 9, because that's what we just found. 30 seconds, the same, the water would have reached h is equal to 9. And because our expression, of course, depends on h. So that's that 2. Don't forget, I just didn't write, I don't want to write it again. Let me just write a half space there. 2 over 2h plus 5, so it's going to be 2 times 9. I'll make it 2 over 23. I don't know what that is, some number. I don't know what this is. But you can't leave it like that. Blah, blah, blah. The units for something like this, they're not required, but the units do help understand the problem. It's units of a height, which, of course, we're in centimeters cubed for the volume, so it's going to be centimeters for length divided by units of time. So 2 over 23 centimeters per second. I hope you followed this. I went a little bit fast, and I'm out of practice normally because I haven't been teaching now for a very, very long time. And normally I do teach kind of like in Richmond University and all sorts of other stuff. And my skill when it comes to sort of more elementary, I'm a little bit out of practice, so you have to forgive me. So this is the end of this particular lecture. I hope you followed what I've just done in there, and you will find this soon in one of my synoptic papers, either X, Y, or Z. But if you go to the related rates of change in the under standard topics, various, in my website, you will find this question. It's a 4.5 question. I'm going to sign out, and I'll see you real soon.